Good afternoon, everyone. Welcome to the class of CE3C1, Environmental Engineering 1 Lab. Today we will discuss how to determine the carbon dioxide in water. Carbon dioxide in water. So what happens that where, where does this carbon dioxide come into the water? For example, this is water, right? And carbon dioxide might be present in the atmosphere, in the air. And from there, carbon dioxide can enter into the water. And when it enters, this carbon dioxide reacts with water molecule to form H2CO3, which is bicarbonic acid. Okay, is it clear, guys?
Yes, sir.
Yes, sir.
So that's the one source, like air. That's one source. There might be a multitude of other sources. For example, if you have this surface soil, and if you have groundwater here, so these things are inside the soil, right? What happens that when different animals and trees die out, then they get deposited into the soil. Now, these are basically organic matter, right? So, this organic matter, with the presence of oxygen or without the presence of oxygen, without the presence of oxygen, by microorganisms like bacteria, micro or organisms, bacteria and other microscopic creatures, break them down. This organic matter break them down. And organic matter is basically what? Organic matter is long carbon hydrogen chain, am I right?
Yes, sir.
And there might be nitrogen and other things, but carbon hydrogen chain has to be there. So that actually breaks down this microorganisms, break it down and forms what? Carbon dioxide. So this carbon and oxygen becomes carbon dioxide, water, and new bacteria or new microorganisms. New microorganisms. So they take them as a food, break them down, and produces new microorganisms plus other compounds. So this carbon dioxide, they are basically, if this is a confined layer here, if you have a confined layer here, then carbon dioxide are basically confined here. Carbon dioxide, this carbon dioxide, right? And under pressure, since they are confined, so they are under pressure, and under pressure they get dissolved into the water. So once they are in the water, they react with water to form what? Bicarbonic acid. Therefore, pH will be what? Higher or smaller?
So
Smaller.
small.
Smaller. So groundwater pH typically is smaller than surface water pH. If you talk about surface, this is a surface, right? You have a surface like a river here. So pH of the surface water will be higher and pH of groundwater will be lower. Why? Because we have carbon dioxide here from the decomposition of organic matters, which were already present in the soil, and in under the soil you have confined layer. So the gas, carbon dioxide gas, is trapped and it cannot escape. So more carbon dioxide are producing. So more pressure is building here. More pressure is building. Therefore, due to this pressure, easily carbon dioxide gas dissolve here. If we increase the pressure, then the dissolve or dissolution will be increased. Dissolution of gas. Dissolution means of gas means gas getting dissolved into the water. Like oxygen can be dissolved into the water, right? And we call it what? Dissolved oxygen. Alright.
Yes, sir.
So similarly, carbon dioxide can also be dissolved, and if the pressure is increased here, pressure is increased, more and more carbon dioxide or gas will be dissolved. So dissolution of gas is proportional to the applied pressure. In groundwater, they are under high pressure, so they are dissolved. They are more dissolved than the surface water. So that's one source. Another source of carbon dioxide into the water. So that's what they're telling here. The total carbon dioxide in water is the sum of free carbon dioxide and the carbon dioxide existing in the form of bicarbonate and carbonate ions. You know, this carbon dioxide H2O, H2O, this can give what? Bicarbonate ion plus hydrogen. And again, this bicarbonate ion can give you what is carbonate ion.
H plus.
Carbonate ion,
And
CO3 2 minus.
so carbon dioxide can be in different forms. This form, or this form, or carbon dioxide dissolved form. Free carbon dioxide. Free carbon dioxide is this one, only dissolved. And the carbon dioxide existing in the form of bicarbonate and carbonate ions. The presence of free carbon dioxide is caused by the decay of organic matter. Decay of organic matter. This is the decay of organic matter. The microorganisms are taking organic matter as a food and breaking them down. That is called the decay of organic matter. Clear? Decay of organic
Yes,
matter.
sir.
Dissolution of carbon dioxide from underground sources and the dissolution from the atmosphere. Atmosphere. I gave the first example. Since the carbon dioxide content of normal atmosphere is quite low, so they're telling that in air carbon dioxide concentration is very low, 0.04%. So air is a very menial or very small source or negligible source of carbon dioxide into the water. Surface water usually contain less than 10 ppm of ppm means milligram per liter, by the way. ppm means milligram per. So usually in surface water, carbon dioxide concentration is 10 ppm, only 10 ppm. While some groundwater sources are found to contain free carbon dioxide exceeding 50 ppm. Sometimes in groundwater, carbon dioxide concentration will be much higher. As I told you, carbon dioxide concentration will be higher in groundwater and lower in carbon dioxide concentration lower in
Surface water.
surface
Surface
water.
water.
Surface water. And carbon dioxide concentration higher in groundwater. So since this is higher, pH will be lower, and since this is lower, pH will be higher because carbon dioxide causes acidity. Environmental significance. Carbon dioxide gas on solution in water produces carbonic acid, resulting in lowering of pH value. I just told you. And thus produces corrosive characteristics. If pH is low, and this is acidic, and that acidic nature may cause corrosion in the pipe which is carrying the water. Severe corrosion of heat exchanger pipes, valves can result where applicable, appreciable. That means good good quantities of free carbon dioxide are present in water. Corrosion from carbon dioxide in boiler system is most frequently encountered in steam and return lines. Even though the boiler feed water contains no free carbon dioxide, appreciable concentration of this corrosive gas may come from carbonate and bicarbonate of the boiler feed water. ECR, Environmental Conservation Rule, Bangladesh Environmental Conservation Rule, does not set any limit for its presence in drinking water. Limits for carbon dioxide have been prescribed for many industrial uses. That means, even though carbon dioxide is very low in water, this is not harmful for our health, but that is problematic in terms of industrial usage. Is it clear?
Yes, sir.
So this is not a problem mainly for drinking water, but this is a problem for mainly for industrial uses. So before you use a water during industrial process, you need to know what is the carbon dioxide content of the water, especially if you are bringing the water from the ground. Then there is more chance that your water contains higher amount of carbon dioxide concentration. So
স্যার
yeah,
স্যার ইন্ডাস্ট্রির জন্য খারাপ কেন?
as I told you that in industry, for example, in industry you are using boiler, okay, boiler machine, it heat, and you are using water. And if this is carbon dioxide rich water, then pH will be lower. That means it has higher acidity. In case of higher acidity, this there will be corrosion in the container because with heat, this corrosion will be accelerated. Boiler feed water. Is it clear?
ইয়েস স্যার।
By the way, what is the pH of Coke? Uh,
So it will be lower.
I don't know, acidity, right? Why?
Yes,
Because
sir.
it has carbon dioxide dissolved in water. That's why.
Yes, sir.
So that doesn't harm us because in our stomach pH is already around 5 because we have hydrochloric acid in our stomach to digest the food. Why Coke is dangerous to I mean soft drinks?
Because sir, it has greater amount of sugar.
Sugar, that's the problem. Sugar. Extreme concentration of sugar, and this is carcinogenic. It may cause cancer. Okay?
Yes, sir.
So theory and experimental method. So what we are doing here basically, what is our objective here? Our objective is to determine the carbon dioxide. And what is carbon dioxide? This is basically an acid, right? Carbon dioxide reacts with H2 as I told you, and produces carbonic acid. And this carbonic acid, how to determine if you carbon dioxide plus H2O, that is carbonic acid. Now you want to determine this. That means you want to determine this. Now this is an acid. Now how to determine the amount of acid? By titration this acid with a base. Simple, right? So titration, are you following me guys?
Yes,
Yes,
sir.
sir.
ইয়েস স্যার।
Yes, sir.
So titration of this acid with a base, for example, sodium hydroxide. it will produce sodium bicarbonate and water. This will produce, I'm sorry, H2SO4, no. This is, why did I make this mistake? This is H2CO3, right?
Yes, sir.
H2CO3. I mean this one. So sodium bicarbonate and water. And sodium carbonate bicarbonate actually remains in form, this form. Sodium plus bicarbonate ion. Sodium ion and bicarbonate ion. So that's what they have mentioned here. Sodium ion, sodium ion and bicarbonate. And this bicarbonate can again react with more sodium hydroxide to produce carbonate ion. Okay. So basically, what you have to do is very easy. Just bring some sample, take some sample of the water in a beaker, 100 ml, 100 ml, and titrate this with sodium. 100 ml of what? Water, right? Water. Now you have what here? You already have. If you have, by the way, if you have carbon dioxide, then you have what? H2CO3. Am I right?
Yes, sir.
So now you want to titrate it with what? Base. In the bullet, what will be there? Tell me. The bullet, what will be there?
So in a which?
Sodium hydroxide base, right?
Yes, sir.
Simple. So you just add drop by drop. Now the question is, when would you stop? When would you know that complete transformation of H2CO3 has been done by the sodium hydroxide? You need an indicator, am I right?
Yes, sir. It will change. The indicator will
The
change the color, I
color.
think.
Let's look at the table now. Need some idea here. We know this table, by the way, acidity table. So 4.5 to 8.3, basically you have H2CO3 and HCO3 minus. Both these and these are good. If it's greater than 8.3, 8.3 the pH, then you have bicarbonate and carbonate. If it's greater than 10.3, you do not have bicarbonate. All the bicarbonate has been converted to carbonate. And you have hydroxyl ion, which came from the water molecule. We already discussed these things, right? And if the pH is less than 4.5, then H2CO3 is undissociated. That means it is not dissociating. It is not dissociating. Is it clear?
Yes, sir.
Now, your pH less than 8.3, the pH less than 8.3 from there to there. This is called carbon dioxide acidity or natural acidity. So from less than 8.3 to the minimum value. This is carbon dioxide acidity. Clear?
Yes, sir.
Okay. You may have further acidity in between 8.3 to 10.3, but that's because of other um, species. From uh, less than 8.3 here, this portion, is basically called carbon dioxide acidity. And these are basically for which species? This species, this species, and this species. Now here, beyond 8.3 to 10.3, you may have acidity, and that is because of other species, like uh, other species. Now beyond 10.3, there is no acidity. Beyond 10.3, there is no acidity. If so, starting from 14 to 10.3, no acidity. From 10.3 to 8.3, that is non-carbon dioxide acidity. You can call it non. You can call it non-CO2 acidity. This from 8.3 all the way whatever you could have, that is carbon dioxide. Then starting from 4.5 and below, that is called mineral acidity. Now in this experiment our objective is to determine what carbon dioxide acidity, and look at the range up to which carbon dioxide acidity prevails. 8.3, am I right?
Yes, sir.
Greater than 8.3, there is no carbon dioxide acidity. So that is not our concern. Our concern is below 8.3. Now we need an indicator who will change the color from a color at 8.3, and that will indicate us that okay, we have reached 8.3. That means all the carbon dioxide acidity has been achieved. And that indicator is phenolphthalein indicator. This phenolphthalein indicator below 8.3, here this is colorless. At 8.3 it changes its color to pink here. So in a sample, this sample, first of all, in this sample you take water. Before addition of sodium hydroxide, if you put before addition of sodium hydroxide, if you drop phenolphthalein indicator this, and you see that the color became pink, what does that mean? That means your pH is 8.3 or greater than 8.3, because this is pink, am I right?
Yes,
Yes,
sir.
sir.
That means, do you have any carbon dioxide here?
No, sir.
No, sir.
No. So you don't need to test any further. You don't need to test sodium hydroxide. I mean, add sodium hydroxide further. If after addition of phenolphthalein indicator, you see the color has changed to pink color. Okay. Now, if you after addition of phenolphthalein indicator, if the color is still colorless, that means your pH is less than 8.3. Am I right?
Yes, sir.
This is 8.3 less than 8.3. So that means we need to, there is carbon dioxide, that means there is H2CO3, there might be, and you have to add sodium hydroxide. So you add sodium hydroxide. For example, your pH was here, I don't know, maybe 7, whatever it is. So you start adding sodium hydroxide drop by drop. And you're adding what? Base. So pH will rise or reduce. Tell me.
Reduce, sir.
You're adding base,
Oh,
It's a rise.
no, sir. Rise.
rise. So rise. So from 7, it will rise to 8.3. And when the instance when it reaches 8.3, it will be pink color. Yes, a light pink color you'll be able to see. And at that point you stop addition of sodium hydroxide. That means that is your end point of the titration. Now you know how much sodium hydroxide you have added, for example 2 or 3 ml. You don't know, whatever is required, and then you calculate phenolphthalein acidity. Phenolphthalein acidity, by the way, we also call it phenolphthalein acidity. This carbon dioxide concentration that can also be termed as phenolphthalein acidity, and that is basically free carbon dioxide, right, in water, equals to multiplying factor into milliliter of 1 by 44 normal sodium hydroxide added. That means this 2 or 3 ml, how much ml sodium hydroxide you have added here, that is this. For example, this value is 2 or 3 ml, 2 3 4 whatever ml. This is the volume which you have added. Now why 1 by 44 normal? Because it is a standard test, and the test standard tells you to use 1 by 44 normal sodium, right? Normal sodium hydroxide. This is a concentration, measure of the concentration. Clear? Normality.
Yes, sir.
And multiplying factor. What is multiplying factor? Multiplying factor is the normality of sodium hydroxide. What is this, guys? Normality of sodium hydroxide 1 by 44, right?
Yes, sir.
1 by 44. You have added this. Now, equivalent weight of carbon dioxide. What is equivalent weight of carbon dioxide? Carbon dioxide equivalent, carbon dioxide CO2. The equivalent weight of carbon dioxide equals to what, guys? Molecular weight divided by valency. Am I right? Huh?
Yes, sir.
The molecular weight is what? Carbon is 12 plus
So 44.
oxygen is 16, 16 into 2 divided by valency. What is the valency of carbon dioxide? It actually takes 2 hydrogen, right? So this is H. I'm sorry, this is 2, 2, and that will be 44 divided by 22, right?
Yes, sir.
So uh, 22 into 1000. We are converting liter, milliliter to liter, and milliliter of sample. How much sample you took? I believe 100 ml.
100
100
ml.
ml. So this is 100 ml. Whatever you get from here, that is the multiplying factor, and you put this multiplying factor here and multiply it with this whatever value you have, and you will get the carbon dioxide. Like, look, free carbon dioxide in milligram per liter. And as you know, carbon dioxide also represents uh, phenolphthalein acidity, right? Phenolphthalein acidity. Why phenolphthalein acidity? Because this acidity is in the range of phenolphthalein indicator color change. So that's why. And phenolphthalein acidity, if you know carbon dioxide concentration, for example, carbon dioxide concentration from here, you got 40 milligram per liter. So by using this 40 in this equation, from this, you will get the phenolphthalein acidity in terms of milligram per liter as calcium carbonate. So this is acidity. So this means once you know the carbon dioxide concentration is 40 40, for example, this is hypothetical value 40. You put it here, and you'll get what? The phenolphthalein acidity in
Phenolphthalein acidity.
in this sample. Okay, now you have to be careful about one thing. For example, if you are bringing a sample from groundwater, you're extracting the groundwater, and this is a sample. Now remember, carbon dioxide was under pressure in the groundwater, but here you have brought it outside, and since you have brought it outside, there is no pressure like this one. Therefore, what would happen? This carbon dioxide, which was dissolved in high pressure, since now there is low pressure, it will get out, it will escape. So therefore, the carbon dioxide concentration you will get by measurement in the lab may not be as may not be the representative one, right?
Yes, sir.
So what you need to do perform this test as soon as possible. And if it's not possible, then what you do, once you collect the sample, immediately you take full, okay, full bottle, and after taking full bottle, you seal the bottle, and keep this in a low temperature room. Clear?
Yes, sir.
Now sometimes you can cross one thing. When you are doing this titration, it takes some time, right? You don't know how much sodium hydroxide you will be adding, so you're putting them drop by drop. That's how you do the titration. It takes some time, 5 minutes, 6 minutes, right? In these 5 or 6 minutes you are stirring them, and what happens, the carbon dioxide may escape out. Am I right?
Yes, sir.
So once you
Yes, sir.
perform the test, for example, you already know that you need, for example, 4 ml. You know you need 4 ml. Now you again do the test, 100 ml, but now not with drop by drop. You immediately put 4 ml immediately, and you check whether there is pink color or not. If the pink color appears, then that means your test was correct. If after addition of 4 ml you see that okay, if it's still not pink color, you need some more 3 or 4 drops. That means for example 4.4 ml. That means this is the correct one. Take this value. Is it clear? What is the difference between this test and this test? Because in this test, since you are dropping one, you are putting the you are adding drop by drop, so it takes some time. That's the problem. Carbon dioxide may escape, but now once you perform the test, now you know you need 4 ml. Am I right?
Yes, sir.
Yes, sir.
So you just immediately drop 4 ml. So you don't need much time. So there is less chance for carbon dioxide to escape from there. So this reading will be more accurate. Is it clear?
Yes, sir.
Yes, sir.
Okay. So that's all. So perform the test, and that's it. That's what they have explained it here. Yeah. Any questions?
Sir, skeptic.
Yeah. Any questions?
No, sir.
Okay then.
No,
Thank you
sir.
very much.